Thank you, everyone, and good evening. Welcome to today's meetup. Today, I'm going to discuss how to guarantee exact consisting with their sub-second latency on massive data. Here's today's agenda. First, we'll take a look at the scenarios where consisting can help. And then we will do a demo to look at the consisting query performance of the mainstream query engines. Next, we discuss how to achieve sub-second query performance in Apache Kylin and what's the technology behind the scenes. At last, we will look at the real use cases provided by the community users. Okay, so first of all, let's take a look at what is consisting. Consisting is a way to compute the number of unique values in a dataset. For example, here we have a table that records the click events of user access in our website. Assume we want to know two very important metrics, PV and UV, which are page view and unique visitors. They indicate how many access traffic we have totally and how many different users our website has. For PV, it's quite simple. Just count how many records we have totally in this table. But for UV, we need a consisting function. In this example, we need to find out their username column and remove duplicate values and count the number of different values. And then we can gather the result of consisting is 3. So quite simple, right? But imagine that if there are tens of billions or hundreds of billions of rows that need to be counted, it will become very complicated and time-consuming. Actually, there are two types of a consisting. One is approximate consisting. It uses statistical estimation method to calculate the results. It's not accurate and allows errors. Approximate consisting is faster and uses less memory and CPU. It is usually used in some trend analysis scenarios. In these scenarios, accuracy is not necessary. You only need to know the general trend and can accept the existence of errors. But in most of other scenarios, approximate consisting is not good enough. For example, if we turn the error into money, it will be more intuitive. Assuming the correct result is $1 billion, if we are using approximate consisting with 1.22% error rate, it may produce an error of $12 million. That's a lot of money. So it is often mandatory to use exact consisting in some scenarios, especially related to transactions and money. Users need to know the exact and accurate number of distinct values in these scenarios. Exact consisting can guarantee the accuracy of results, but it is slower than approximate consisting and requires more computing resources. Suppose you advertise your product and pay according to the numbers of clicks. Then you definitely don't want the billing to be measured by approximate consisting. Okay, let's go ahead to look at some common exact consisting scenarios. The first one is the data analysis of website or mobile applications. When analyzing the usage of website or mobile applications, we often need to understand some very important metrics or some other questions. For example, what type of people are our users? Where do they come from? What kind of people are most interested in our product? This can help us better target customers. There are also two very important and frequently used metrics here. One is unique visitors, UV. Another one is the daily active users, DAU, or monthly active users, MAU. Decision makers, marketing, and product people all need to know these metrics to help them to make strategies to improve product and make profit. To get those metrics, you have to use condistinct functions and often exact condistinct. Another common scenario is the user behavior analysis. Retention analysis is frequently used, which analyzes the number of customers who visit continuously in a different time period. For example, 10,000 customers used our product on Monday. So how many of them continue to use our products on Tuesday? How many is left on Wednesday? Retention analysis helps us understand customer loyalty, identify the audience, and also helps analyze products that can be improved to retain customers. In order to calculate the retained users, we need to perform deduplications calculations on the daily users. Exact condistinct is required in this step. If the number of users and visits is huge, then retention analysis will have higher requirement on the performance of the query engine. I guess it won't be a pleasure experience if you pick a date range on this chart and have to wait for 10 minutes or even half an hour to get the result. We need interactive analysis here. Performance is very important. Another scenario is a funnel analysis. For those behaviors, including a series of steps, users may be lost in any step of them. For example, a purchase behavior, users need to do a couple of operations to complete a purchase. We need to analyze these steps to find out which step has lost more users and can be improved, or analyze what type of customers are more likely to be lost in a certain step. Let's go back to this example. If we observe the flow of a purchase behavior, the customer will first enter our shop and then view the details of products, check out, and complete the purchase. Assuming that through the funnel analysis, we observe that more customers are lost during the checkout step, then it is likely that our checkout experience is very bad. Do customers have to wait in a long line? Or is the system stable enough? With such analysis, we can improve the user experience, thereby retaining more customers and facilitating more orders. To achieve this, in each step, we need to perform deduplications and know the exact number of users lost in each step with exact condistinct. Okay, so we already discussed what scenarios need to use condistinct, why it is very important for those analyses. And we also know that there are two kinds of condistinct, of which exact condistinct is very important for many scenarios. But on a very large data scale set, performing exact condistinct is always a big challenge. So next, let's analyze from the perspective of technical principles why exact condistinct is so difficult and how Apache Kylin solves this problem. Earlier, we mentioned that approximate condistinct is simpler than exact condistinct. Actually, there's a mature and proven solution for approximate condistinct already in the big data industry, which is Haplolog. We're not going to discuss too much about this algorithm. Let's focus on the exact condistinct. For exact condistinct, when processing massive data, it will face the following challenges. The first one is the data volume. It needs to scan all data, which will lead to a poor query performance. Secondly, because the condistinct matter is non-cumulative, it's impossible to derive the relevant value from the calculated value. For example, if we calculate the UVs for 7 days a week, and then we want to know the UV for the whole week, we cannot simply accumulate the 7-day data together to get the result. The results still need to be recalculated from the original data source. Similarly, in addition now being able to do rollup operations, we cannot directly perform other logical calculations. And even only one exact condistinct needs a large amount of calculation. How about the whole dashboard? It will generate several exact condistinct queries at the same time. So good luck to you if you have to refresh this report. All right, so we talked about the exact condistinct challenges in large amount of data. You may still not believe it, So let's take a look at the performance of the current mainstream query engines, how they perform distinct queries on large amount of data. We choose Google BigQuery, Snowflake, AWS Athena, and Kyligence as the comparison. We will use the same data source for testing, which is TBC 1000. It is a popular benchmark dataset in big data area. Okay, let's take a look at this demo. So first of all, let's take a look at the Snowflake. This is a UI of Snowflake, and we have a built-in dataset, the TBCH scale factor 1000, and it contains 1.5 billion rows in these order tables. Let's run this simple query to get the distinct of all the key from this table. First of all, let's clear the cache, and then let's run this query. Okay, it's already running, and we are not going to wait here. So meanwhile, let's switch to BigQuery. This is the Google BigQuery, and it's a SaaS service provided by GCP. It can query data stored in the Google Cloud. We have the same data stored in Google Cloud storage. And we will run the same query against the order tables. All right, let's run this query. So it's running, and you can see the timer is started. And let's go ahead to AWS Athena and move it. And again, the same dataset, the same tables, and the same columns. We run the condensing queries against this table. Okay, it's running. All right, let's switch to Apache Kylin. Again, the same table, same query. Let's try to run it. We already have the result, 1.5 billion rows. And it answered in 0.18 seconds. If you can see the cubes here, it means this query answered by the cube. The cube is defined in Apache Kylin to accelerate the query. All right, so we have the 1.5 billion rows and in 0.18 seconds. Next, let's go to the Kyligence. Kyligence is a commercial version of Apache Kylin. So we have 10 times larger data than previous demo. Let's try to run the exact same query against a 10 times larger data volume. Okay, it's 0.5 seconds to get almost 10 times data volume. It's 11 billions of rows. And it also answered, yeah.
We can't see that screen. We're still on the presentation.
Oh, really? Let me share it again. Can you see the browser?
Yes, now we can.
Okay, so from the very beginning, you cannot see the browser, right?
Right.
Okay, so let me show this again. So let's just run the query again. So this is a Snowflake, and this is a query we run against a Snowflake. It's quite simple, and we just run the query against the table and fetch the distinct of the all the key, and let's run it. Okay, so we need to clear the cache and run the query again. All right, so it's running, and let's go to Google BigQuery, and the same dataset, same table, and same query. Let's run it. All right, it's already running, and you can see the timer here. Let's go back to Athena. Again, same table, same query. It's running. Apache Kylin, yeah, again, same table, same query, and that's right. It's 0.16 second to fetch the 1.5 billion rows. And it's an exact consistent. Oh, it's not. I put the wrong. Yep, let's try it again. Okay. And let's switch to Kyligence. So in Kyligence, we are using 10 times larger data volume and the same table, same columns to get a consistent. So it fetched the result in 0.49 seconds to get 11 billions of rows. If you can see the number exactly, it's 11 billion rows. How about Apache Kylin? Okay, it's 8 seconds. Let's have another execution. Okay, this time it's 6 seconds. Yeah, sorry, maybe I put the wrong query before. All right, so 6 seconds, not bad. And if we switch to Athena to check the result, Athena spent 22, almost 23 seconds to fetch the result from 1.5 billion rows. How about BigQuery? BigQuery spent 1 minute and 33 seconds to get the result. The number is exact the same, 1.5 billion rows. And let's take a look at the Snowflake. Snowflake spent 2 minutes and 4 seconds to get the result, and the result is correct. All right, so that's a comparison testing between those query engines. I have a, let's switch back to their presentation. I have a summary of their query result. So yeah, their Apache Kylin may be a little not accurate because I'm using not consistent to make this graph, but it's still better than other query engines. So if you can see the result, Snowflake spent almost 2 minutes to fetch the result, and then it's Google BigQuery. So AWS is better, and Apache Kylin have the best performance. All right, so next, let's talk a little about Kyligence. So you may notice that Kyligence has the best performance. Kyligence is the commercial version of Apache Kylin. Let me give you a quick introduction about Kyligence. Kyligence is Kylin plus intelligence. It was founded by the creators of Apache Kylin in 2016, and it provides enterprise features on top of Apache Kylin by leveraging AI technology. Kyligence makes their OLAP models and cube smarter, gain better performance, and reduce significant maintain efforts. Kyligence is keeping leading and contributing to open source community. Just like other open source projects, there are always commercial companies behind the open source project to help make the community better. For example, Spark and Databricks, Hadoop and Cloudera, Kafka and Confluent, etc. All right, so let's go back to Apache Kylin. And we already demonstrated that Apache Kylin have very good query performance on their large data volumes to gather exact consistent result. So how does it work? What are the technical principles behind it? Let's take a closer look. In fact, the principle is not complicated. There are 3 key points: pre-aggregation, bitmap, and dictionary. So let's take a look at them one by one. The first one is pre-aggregation. Pre-aggregation is the core principle of Apache Kylin. By calculating the result to be obtained in advance and storing them in the cube, it avoids a lot of on-the-fly calculations, so that saves significant time and computing resources on each query. Let's take a look at this example. In this table, we record the website page that user visited on different days. Suppose we need to calculate 2 measures, PV and UV. Through pre-aggregation, we can store the result in another table. For example, we stored PV and UV for 2020 April 1st in a new record of this result table, and add another record to store result of April 2nd. And then when the query comes, we do not need to scan the original table here. We can just fetch the result from the intermediate table directly. And in addition, what if we not only want to understand the daily situation? What if we want to know the summary of past 2 days? What should we do? Can it be summarized directly from the result of the past 2 days? However, for PV, the answer is yes. We can just get the 2 lines and add those 2 results to get the final result. That is the PV for the past 2 days. But as we mentioned earlier, consisting is non-cumulative, so we cannot just add the intermediate result to get the final result. So it seems like pre-aggregation does not work in this case. Let's think about this again. The reason why consisting cannot be accumulated is that the consisting result here is just a number. It does not contain any information that can be used to do a calculation again. If we can store some information in the intermediate tables, and then we can use this information for the second round aggregation, that means we can make consisting pre-aggregatable. In order to make this happen, Apache Kylin introduced another data structure to store the information. That is a bitmap. So what is a bitmap? Bitmap is a special data structure. It is used bit to indicate whether a value exists in a dataset. Everyone knows that the smallest unit of information stored in a computer is bit. And the use of bitmap can effectively save the storage. If the capacity of the original data is very large, storing the original value directly consumes huge memory and storage. Then it's a good option to store it by converting to bits with bitmap. For example, as shown in this figure, the UID is an integer type, which occupies 4 bytes, that is 32 bits. And we can reduce the storage space by 32 times by converting it into a bitmap. How can we do that? Actually, each UID can be mapped to a bit based on their value. Let's take this first row as an example. The value of the UID in this first row is 1, and then we can mark the first bit in the bitmap as 1. Again, so the value of the second row is 2, and then we can map the second bit in the bitmap as 1. So by this way, we can convert all the record in the original table to a bitmap. Bitmap can not only save storage, the operations of bitmap can effectively use computer native instructions to perform faster logic operations and have higher performance than raw data. In addition, bitmap often have other compression methods which can make the storage even smaller, such as using different storage structures according to the sparseness of the data, or storing consecutive numbers briefly. Actually, there are many bitmap implementations. In Apache Kylin, we use roaring bitmap, which is a bitmap implementation with very good performance and has been used by many mature products. Okay, so let's see how Apache Kylin use bitmap to implement consisting and make it pre-aggregatable. Instead of storing the pre-aggregated result in the result table directly, we use the bitmap. We store the bitmap in the intermediate table, which is a cube in Apache Kylin. And then we can use the bitmap to do another round aggregation again. So like this. And then we don't need to go back to the original table to scan all the data again. We can just use this two line to calculate the final result. So that's how Apache Kylin used Bitmap to make their distinct pre-aggregatable. Okay, so are you still awake? Hold on, the boring part is almost over. In addition to great saving the storage cost and the support rollup, Bitmap also provides additional logical operations such as AND and OR. The AND operation can extract duplicate elements in the two result set. AND operation is usually used in retention analysis and funnel analysis. An OR operation can combine the data of two sets, which is very useful in the scenario of a multi-dimensional analysis. All right, so we learned that Apache Kylin used pre-aggregation and Bitmap to achieve sub-second query latency of exact and distinct. But meanwhile, we also know Bitmap can only store integer type values and cannot handle string type values. In the business, we often need to use string type values such as user emails and user names, etc. So how does Apache Kylin handle this type of data? To solve this, Apache Kylin introduced the concept of dictionary. Dictionary is a common encoding method which converts character strings into numbers by one-to-one mapping. So for example, in this table, we have the username stored as integer as a string type. And then we use the dictionary to map the string to integer. And then we can use the bitmap to store the integer as we mentioned before. So the problems tend to the previous one we already discussed. And then we can use the bitmap to do the pre-aggregation again. So that's how Apache Kylin handles string type data with bitmap. All right, so that's all three key points of Apache Kylin to accelerate exact and distinct. Now, let's take a look at use cases shared by other users in the community. The first use case is from Manbang, which is the largest Chinese track logistics startup company. There are more than 7 million registered trucks and 2.25 million active users. They have currently launched 8 mobile applications and generated more than 10 terabytes of data in the last 2 years. They hope to use Apache Kylin to do retention analysis and funnel analysis on a wide range of dimensions and data ranges. In addition, they also hope to use Apache Kylin for user profile analysis. This is the technical architecture diagram of Manbang. Let's take a look at this diagram from left to right. Manbang collects data from mobile application, websites, and log files. The data is sent to Kafka, and then the data is divided into 2 processing methods according to different types. One is sent to Hive. After some ETL jobs, it is loaded into Kylin by day. Another kind of data with real-time requirement is directly connected to Kylin for processing. Apache Kylin is responsible for modeling data and pre-calculation work and exposing query services to the front end through RESTful API. Here's an example of retention analysis in Manbang. Because Manbang is a Chinese company, so we only have this Chinese version screenshot. I hope this won't affect your understanding about this case. Manbang independently developed this front-end analysis system to provide self-serving analysis for end users. So analysts, they can choose the type of behaviors by themselves, and they can choose any data range in this chart. After submitting the filters, retention rate can calculated at the millisecond level and returned to the user quickly. This greatly improves the analyst's work efficiency. At the same time, it is hoped that the analyst can perform a flexible funnel analysis. compared with the traditional fixed template funnel analysis. They hope that users can combine different steps to customize the funnel so that the business can be flexibly analyzed to find the weakness and for improvement. Users, they can choose any two steps in this funnel, and the details information of lost users will be shown quickly in this table. Analysts can export their user information in this table for further promoting events. Another case is from Didi, which is the #1 rideshare company in China. The latest figures show that in December 2019, their monthly active user reached 92 million, and the average daily order for the year was 24 million. Didi mainly use Apache Kylin to perform user profile analysis and precision marketing. Using Apache Kylin to build user profile, you can conduct precision marketing based on user portraits. For example, by analyzing different user categories, find a specific type of users, and send coupons to them to promote their consumptions. Similarly, in order to increase customer loyalty, Didi will also select specific types of users based on user tags and upgrade their cars for free. Through this kind of activities, Didi increases customer stickiness. In addition, for some promotional activities, the results need to be analyzed to evaluate the effectiveness of their activities. Through the statistics of new customers or returned customers, we can determine whether the activities have achieved the expected result and thus decide whether to continue to organize similar activities or improve the activities. In the processing of determining the target user groups, a larger number of exact consistent calculations are included. In a traditional way, it usually took several days or even weeks to group users to calculate the calculate the tags of users. Apache Kylin helped Didi reduce this workflow and help analysts get the result very quickly. All right, so at last, let's take a look at the use of Apache Kylin in Didi. At present, the amount of data processed by Apache Kylin exceeds 200 terabytes, and they are distributed on more than 5,000 cubes, and more than 7,000 tasks are running every day. There are a total of 7 clusters are set up to cover multiple business lines in Didi. Okay, so that is all I want to share today. And if you find it helpful and you are interested in Apache Kylin, please don't forget to join us. You can participate in the community by the following 3 ways. You can fork our project in GitHub, and you can also subscribe our mail group. And you are very welcome to join our Slack channel. Okay, so finally, thank you very much for joining today's meetup. Thank you again.
Okay, awesome. Thank you so much, Kai, for your presentation. I see some questions on the chat if you would like to answer them. So the first question that we have is, how do we integrate Kylin with ETL jobs?
Yeah, so that's a very good question. So Kylin can be integrated with any mainstream ETL framework. And Kylin provide the RESTful API. You can use any tools or your self-developed tools to call the RESTful API to integrate it with your ETL jobs. For example, if the data is ready, and then you can call the RESTful API to load the data to Kylin and build a queue. After that, you can tell their end users the data is ready for their query.
Okay, great. All right, next question. Is it possible / reasonable for traditional relational table entries to be kept in sync with Kylin by containing updatable references to dimension and measure IDs, sort of like foreign keys?
Yeah, so uh, this question actually is related to the how to do the modeling in Apache Kylin. Apache Kylin can support uh, basic snowflake or the star schema, just like what you did in the traditional database. Any schema you have in the traditional database can be migrated to Apache Kylin. So it doesn't matter you are using a surrogate key or you're using their primary key or formula key. They all can be supported in Apache Kylin.
Great. Can you tell us about Kylin's new storage engine?
Yeah, that's a very good question. So during the last year, the community are working on their new storage engine. And as we all know that currently Apache Kylin can support HBase as their storage engine. So that means all the data processed by Apache Kylin will be stored in HBase. And we are leveraging the processing capability of HBase to answer the queries, and which is very good, but it also has some limitation. For example, the HBase cluster is not easy to maintain, and it has some query performance issue with very complex queries because HBase is not a true a column-based storage, and um, and again, because we need to convert the cube data to H file, because HBase has its own data format, that also make the job building slower. So considering about these limitations, we are plan to develop a new storage engine, and our goal is to design a new storage engine which is cloud friendly and which is can be scaled horizontally and which can improve the query performance and the building performance. So actually, right now we already have a alpha version for this new storage, which is based on the very popular the column-based storage Parquet, Apache Parquet. And if you are if you are interested with this new storage, I will recommend you to subscribe our mail group, and there are a lot of information shared in the community.
Great. What can you tell us about the new features in the latest release of Kylin?
Yeah, so the latest release of Kylin, either Kylin 3.0. And in this latest version, we released the major feature is the real-time streaming. So actually from the Apache Kylin 1.6 version, we can support near real-time features, which means when the data is ready, you need to wait for a couple minutes to processing the data, and then you can access the data. So there are a couple of minutes gap between the data ready to the available for the end users. And in the latest version, we fixed this gap and we design a totally real-time architecture. And once the data is ready and the user will can accept the data directly. And it can also be used together with batch data. So we can support a Lambda architecture. You can use the batch data to make sure the data quality and use the streaming data to fulfill your real-time requirement. So that's a major feature in the latest Apache Kylin version.
How does Bitmap handle a lot of different attributes? Your example only counted UID by one attribute date.
Yeah, that's a very good question. So um, Yeah, to be honest, if we want to handle different attributes in the bitmap for exact consisting, that will make the building job slower because you know the exact consisting will spend a lot of resources to calculated. But we also have some best practice. But first of all, for the answer is yes, we can support different attributes in the bitmap. And but you need to be careful about that. So we have some best practice about how to optimize the cube to store multiple exact consisting for different columns. I will recommend you to search this information in our website, or maybe we can discuss offline about this because this is too detailed. But this is very good question.
What are the limitations and queries you can make?
Actually, there's no limitation on the queries. Apache Kylin support the ANSI SQL, so all the features ANSI SQL can support, Apache Kylin can support. So if you are not using ANSI SQL, for example, if you are using the dialect of Oracle, or if you are using the PostgreSQL syntax, maybe you need to change their syntax to ANSI SQL. That's the only limitation I can think about right now.
Got it. Last question that we see. I've seen some work being done with building a Kylin on Druid setup. Would you happen to have any insights on the advantages and drawbacks of replicating such a configuration?
Yeah, so the Kylin on Druid is their proposal by their, if I remember it correctly, it's by a Chinese company called Meituan. And this is not official features in Apache Kylin. So I would suggest you to use the new storage engine because that will have less limitation. As you said, there are some drawbacks of this solution, and you need to carefully take care about the Druid cluster and to set up those definitions and configurations of the Druid cluster. So yeah, this is a very complex topic. We can discuss this in the community. I don't have a short answer for this question, but this is definitely a good question, so we can discuss more later.
Awesome. Yeah, so if you guys have any other questions that are a little bit more complicated to answer right now, feel free to reach out to Kai. We'll on the presentation and recording, we'll have their contact information as well as the recording of this presentation will be on the YouTube. So you guys can revisit that. And with that, we'll wrap up our presentation today. Thank you guys so much for joining us for our first virtual meetup. And look forward to seeing you guys again. Thanks, guys.
Thank you. Thank you, guys.